And now a submission from BattlePigMac or Florian, depending on what you prefer. And you say you've just started working on your PIDs using Blackbox. First, you increase D-term cut hertz 10 to 20, which removes the remaining noise on D-term. So I can't tell if I'm coming in on the middle of a story here because you say first you increase the D-term cut hertz 10 to 20, which I would say if you've just started working on your PIDs, that do not do that. Many copters can fly very well and better with no D-term filtering. And you say, well, hang on, the D-term looks really noisy. It looks like there's a lot of high frequency noise in it. And I say, yes, but the more filtering you have, the more delay there is. So you have a D-term cut of 10 or 20, and now you've added perhaps a millisecond and a half of delay. And don't hold me to that. I haven't got the table in front of me or the calculation to figure out, but something like that, right? And that means that the D term is more delayed relative to the P term, and therefore it's less able to do its job. So when we first, way back when, started working on Betaflight, and by we I mean Boris, and I was just sort of following along, eating little crumbs that he throws down to the masses, right? The first thing he tried was he sort of filtered the D term very heavily, right? We were filtering it like, a cutoff of 8, okay? And we found that it didn't work as well. It was very beautiful, smooth lines in the black box. They looked so good, but the copter's ability to handle prop wash, for example, or its ability to sort of crisp up the end of flips and rolls was hampered. And then we found that if you actually filter the D term less, the lines look noisier, but the copter flies better. So, also, you say you increase D term cut hertz to 10 to 20, but wait, remember, the default for D-term cut hertz is 0. And what that means is that there is no low-pass filter on the D-term. Well, actually, there's an average. There's a moving average, which is kind of like a low-pass filter, but it's a simpler one, and it defaults to 4. I think 4. I've got mine at 8 because I've added a little filtering as well. Again, that's adding a little bit of delay. Regardless, that's neither here nor there. When you take this from 0 to 10, you haven't increased it. You've radically decreased the filter. You are filtering a lot. Remember, the lower this number, the lower your cutoff, and therefore the more you are filtering. So, except at 0, it's disabled, right? Oops, so that's nothing, okay? So if you wanted to try filtering your D term, what you would do is you would start at a relatively high number and work your way down. Don't start at a low number and work your way up. Okay, so if you feel like your D term needs filtering, and by the way, I would advise you that you should try to tune your copter with no D term filtering, and only if you become convinced that no, you really need it, should you try it. And then you may be able to, for example, if you filter the D term more heavily, you may be able to raise the D gain, and you may find that that works better for you. But first try tuning like this. Regardless, what you would do then is you would start at a value of like D term LPF hertz equals 60. Maybe, and work your way down from 60 to 50 to 40 to 35, okay? And find out where the sweet spot is. Don't go from 0 to 10, because that's going from none at all to really a lot of filtering, okay? Okay, enough said about that. Also, if you really want to explore this, play with the D-term average count. The D-term average count is a simpler filter and is, I believe it's lower latency than the D-term LPF hertz. So if you want to clean up, just shave off the sharp edges of your D-term a little bit, set your D-term average count from 4 to like 8 or maybe even as much as 20 and see how that works for you compared to this. Play with it. Okay. Enough about that. Let's take a look at the rest of your tune. Why is the I term of the pitch axis constantly high? Positive I term means it's the result of aerodynamic effects in forward flight. The aerodynamic effects on the copter in forward flight cause it to have a pitch back force applied to it, and therefore the I term rises to counteract that. That's completely normal. Don't worry about it. Low frequency oscillation on the P term of both roll and pitch axis. Well, let's have a look. We'll have a look at roll first, and we'll look at the gyro. I think I do see what you're saying. It's a little hard to judge because you're flying, but yeah. No, here you're pretty clean. Yeah, no, I see what you're saying. Yeah. So, it's possible that that is some kind of vibration causing a beating effect, a harmonic effect. So when you have two things that are slightly out of phase with each other, and you get a low frequency component come through. Let's look at your gyros. Yeah, I think your gyros are relatively. Your pitch gyro is they're not as clean as they could be. So here's the thing, you had problems with your D term, so you added some D term filtering, but the problem you're just covering up the underlying problem, which is that you kind of have the yaw noise. I think is pretty normal. Yeah, it's just this is noisier than I would expect, but it's not noisy enough that I think it's causing a problem. However, the problem, if it does cause a problem, the problem that it will cause is that your D term will be a little noisier, and you will not be able to raise your D gains as high. So it's possible that that filtering the D term is the right thing to do. Although, as I said, don't go from 0 to 10 or 20. Go from 0 to 50 or 60, and then work your way down. The low frequency oscillation, I would raise the I gain. We don't have a command line dump here to see what your I gain is. But if there's low frequency oscillation on the order of about 2 to 4 hertz, I would raise the I gain. That's what I would do. And that will hopefully help sort that out. I'm not sure why you're suggesting that you would lower P. If you're having P term oscillation, then we would think about lowering P. But if we zoom in here to 100%, do we see P term oscillation? Let's go to the high throttle scenario. No. Not even close. And then you drop the throttle and fall, and what happens when you raise the throttle? No. See, the P term wakes up and gets active when you drop and catch the copter, but nothing like oscillation is occurring. No back and forth sine wave type activity. So no, there's no reason to drop your P gains here. All right, so to sum up, I agree that your gyros are noisy. They're not super noisy, but since you're not going to run out and buy a different set of motors and different set of props and figure out where that noise is, maybe even you need to switch frames to get your noise level down because your frame isn't stiff enough. I don't know. I'm not saying any of that's true. I'm saying if you wanted to just say, I'm going to make those gyros look so clean, then those are all things you might do, but who's got time for that, right? So your gyros are not so noisy that I think they would cause a sort of a real problem that needs solving. So, but they are going to limit your ability to raise your D term. So your thinking that you may want to filter your D term is correct. You may also play with gyro filtering, which will clean up the D term. So you could do, the gyro cut hertz. That's, it could go either way. No reason to lower your P gains at all. In fact, you might even raise them. All right. I hope that's all helpful. Oh, and raise your I gains if you have low frequency oscillation like 2 to 4 hertz. By the way, that may sound backwards because traditionally low frequency oscillation is the result of excess I gain. So why am I telling you to raise your I gains? And the reason for that is that I haven't seen high I gain cause low frequency oscillation since like I was flying a multi-Wii board or a KK board, okay? Betaflight, I feel like once upon a time when I was making my mini quad tuning videos, I raised my I gain all the way to 255, which is the max, and I still didn't. And this was not with Betaflight. This was just with CleanFlight like 1.9. I raised it to all the way to the max and still didn't get low frequency oscillations. It flew like shit, but it didn't oscillate. So I feel like if you have low frequency oscillations on a noisy copter, what you're seeing is some kind of effect of the noise, like an aliasing effect perhaps coming out, and that the thing to do is to sort of clamp down on that. And so I would try raise, if I knew what guys, you got to submit your command line dumps, right? The more information you give me, the more I can help you. You don't have to, but see, now I can't make a suggestion. So I would say try raising I gain and see if it goes away and if the copter still flies well. You could also raise P gain. Your P gain seems like it's not super high, and so you could have. I always say try to solve the problem with P gain first, but on a low frequency oscillation like this, I think it's less likely that P gain, cat, is going to be an issue, is going to be able to help you. So, hello. And there's a cat here. All right, well, I have to go pet my cat, and for the rest of you guys, happy flying.